Good morning, everyone. Welcome to our lesson. We have our lesson title, Computing Measures of Dispersion. We also have our learning target this morning. At the end of this session, the students will be able to identify the appropriate measures of dispersion for the given data set, and we're going to compute the appropriate measures of dispersion in real-life situation. To begin with, we have here our content notes. Let's know the process in how to get a certain measure of dispersion. Let's have her first, the range. In finding the range, we need to follow this process. We need to know the highest value and its lowest value. So we have our formula for our range, highest value minus the lowest value. The result of that is our range. As easy as that. In getting the interquartile range, or the IQR, let's do the process. Let's follow the process to find the interquartile range. Step number 1, put the numbers in order, smallest to highest. So we're going to arrange the number from lowest to highest. Second step, we're going to divide the data into a lower half and the upper half. Don't include the median if you have an odd number of data points. If the given data is odd, the middle number there after arranging it, do not include it. So if it's even, so we can divide it from the lower half and the upper half. Step number 3, find the middle of the lower half. This is called the first quartile, or the Q1. So we're going to do that process later. Step number 4, we're going to find the middle of the upper half. This is called the third quartile, or the Q3. So we're going to find that later also. And the last step is we're going to compute the IQR. So in computing the IQR, we need to subtract the Q1 from Q3. So the formula is IQR is equal to Q3 minus Q1. So that's the step on how to find or how to get the interquartile range. Okay, what are the steps in finding or in computing our variance? Our variance here, this is our symbolizes our variance, the S squared. So we're going to follow the steps in finding the variance. Step number 1, compute the mean of the data. So you know how to compute the mean. We will find out later, and we will know later. Step number 2, find each data point's difference from the mean value. Take note, you can use the make a table strategy to organize your data. Step number 3, we're going to square each of these values. Step number 4, you're going to add up all the squared values. And take note, it's solved using sigma notation here. That's our summation. And then step number 5, divide the sum of squares by n minus 1 for sample. So our example later is just a sample data. It's not population, it's just a sample. So this is our formula for going to find our variance, or this S squared. Again, it symbolizes the S squared. So S squared is equal to the summation of x minus x bar squared, or to the power of 2 all over n minus 1. So that's our formula. And take note also, this is it represents our formula here, the S squared. That's our sample variance, the symbol. This sigma here, this is the summation notation, which means sum up or add the numbers in the data set. And then x here, that represents each value in the data set or the given data. And then x bar represents the mean of all values in the data set. And n here, this one, n, it represents as the number of values in the data set. So you're just going to count how many data, and that's represent the n. And in finding the standard deviation, easy as take the square root of the variance. So your answer here, you're answering the variance, you're just going to square root it. And that's our standard deviation. And S, it symbolizes our standard deviation. let's have our example here. Let's compute the range in its interquartile range, or the IQR. Let's have our problem. Let's read it. You are analyzing the population density of different cities in a country. The population densities vary greatly, with some cities being much more densely populated than others. Population density, these are the people per square kilometer. So these are the following data given: 500, 1,000, 200, 1,500, 800, 300, 2,000, and 1,200. Again, we're going to compute the range and its interquartile range. First thing, we need to compute the range. We can recall the process and how to compute the range. We have range is equal to the highest value minus the lowest value. So just spot the highest value and the lowest value. So in this given data, the highest value is 2,000 here. So we have 2,000 subtracted from by the lowest value, which is 200. Yeah. So again, highest volume is the lowest value. 2,000 minus 200, we have our range is 1,800. Wait. 1,800. So this is our range. This is our range. Let's circle that one. Again, this is our range. 1,800. Again, if we can recall, just subtract the highest value and its lowest value, and then the result is our range. Next thing, I'm going to erase this one. Let's compute the interquartile range, or the IQR. In computing the IQR, first thing, we're going to put the numbers in order. So we're going to arrange the data from lowest to highest. So we have 200. Next is 300. Next one is 500. Next is 800. Next one is 1,000. Next is 1,200. Next is 1,500. And last one is 2,000. So again, we have 8 data. Count it off. 1, 2, 3, 4, 5, 6, 7, 8. So next step. Second step, we're going to divide our data into a lower half and upper half. And take note, if the given data is odd, or in Bisaya, bungkig, na ay center, na nasa laag, do not include it. Since our data is even, 8 datas, walay bungkig sa 8 na data. So, pwede siya ma-upper half and lower half. Again, if bungkig siya, do not include the middle. After arranging it, na middle, ayaw siya i-appeal if bungkig siya. So again, step number 2, we're going to divide it into a lower half and upper half. So LH na lower half. We have here lower, gagmay 1, 2, 3, 4. Pat sila, this is our half, upper half here, upat pod, katagko. So we have 200 atong lower half, 300, 500, and 800. Ang atong upper half, we have, sorry. Let's erase that one. Upper half, here, 1,000, 1,200, 1,500, and 2,000. Okay? So after identifying the lower and upper half, we're going to solve for the quartile 1, which is the lower half, and finding the quartile 1, this is our way. So Q1, we're going to, again, here, the lower half, we're going to locate the middle, which is 2 middles here. Just add that 1, 300 plus 500. That's 800, and then we're going to divide that 1 into 2. So 800 divided by 2, that's 400. That is our Q1, or the quartile 1. Next one is we're going to find the middle of the upper half. This is called the third quartile, the Q3. Third quartile, or the first quartile on Q1. Same process here in the upper half. We're going to identify the two middle numbers after arranging it, 1,200, and then add it with 1,500. So we have 2,700. And the same thing, you're going to divide it 1 into 2. So our quartile 3 or the third quartile is 1,350. Next step, we're going to compute the IQR by subtracting the first quartile from the third quartile. So we have IQR is equal to quartile 1, quartile 3 minus quartile 1, or the first quartile. So we have the result of our Q3 is 1,350 minus our Q1 is 400. So our IQR is equal to 950. Okay, so that's the process in how to get the IQR, or the interquartile range. So therefore, the interquartile range, or the IQR, for the population density data is 950 people per square kilometer. Let's have here our another example here. Identify and compute the appropriate measures of dispersion for the daily temperatures recorded over a week. So we have our given datas. We have 2, 4, 6, 7 datas, 22, 23, 21, 25, 20, and 24. 24 and 22. So we have 7 datas given. So in this problem, we're going to compute the variance and its standard deviation. So in computing the variance, we need to follow the formula given and the steps given. Again, formula, and then follow the steps there. So we need to write it first, the formula for our variance. Variance, it symbolizes the S squared. So we have here our formula is summation of x minus x bar to the power of 2 all over n minus 1. So this is our formula for sample variance. All right. Next one, step number 1, in computing the mean. Step number 1 is Step 1, we need to compute the mean of the data. Again, that's the step number 1. Mean represents as the x bar. So if you can recall our previous topic of previous lesson on how to compute the mean, we're just going to add all the datas and divide it on how many datas given. So we have, add all the datas, 22 plus 23 plus 21 plus 25 plus 20 plus 24 plus 22. And then divide it on how many datas? 1, 2, 3, 4, 5, 6, 7. So that's 7. So if you're going to add all that given datas, the result is equal to 157. That's the upper portion. So divided by 7, the result, or our x bar, or our mean, is equal to 22.43. Take note to round it off into 2 decimal places. So you round off siya into 2 decimal places down. So this is our mean. Take note of our given mean. So let's erase this one. Let's take note for our given mean. Again, our mean, or x bar, is equal to 22.43. Our next step, step number 2, we're going to find each data point's difference from the mean. So we have, again, the formula, n minus 1. Don't forget the formula. So again, this is our x bar, represents as the mean. Step number 2, the datas and the mean. Since the formula here represents the data given and the x bar, which is the mean. So let's use the make a table strategy to put all the datas. X here represents all the data. We have 22, 23, 21, 20, 25. We have 21, 25, 20, 24, and 22. So these are our datas. 1, 2, 3, 4, 5, 6, 7. Given datas. And our x bar represents 22.43. Again, here in our formula, it says here x minus x bar. So again, our data, and we follow here x minus x bar. So our data given here, 22, since we're following the formula here, to put it later in our formula, in our general formula, 22 minus x bar is 22.43. And then 23, that's 1, minus 22.43. And then our 21 data, 21 minus 22.43, the same process, 25 minus 22.43, same process, 20 minus 22.43, and then 24 minus 22.43, and then 22 minus 22.43. So if we're going to get the answer there, 22 minus 22.43, we come up with negative 0.43. Here, 23 minus 22.43, we have 0.57. Kanisha, 21 minus 22.43, we have negative 1.43. 25 minus 22.43, we come up with 2.57. And then 20 minus 22.43, we come up with negative 2.43, in wala. 25, wala siya, 2.57. Next one, 24 minus 22.43, we have 1.57. And then last one, 22 minus 22.43, we have negative 0.43. So these are our x minus x bar squared. Kani siya itong mga answers. Kani siya. Negative 0.43, 0.57, negative 1.43, 2.57, negative 2.43, 1.57, negative 0.43. Okay, take note of that. Next step, we're going to do it in squared. The result, atong i-squared ang result. Ato sang i-erase dari nga side. Ato na lang i-continue. Ayan. So, x minus x bar squared, since that's our formula sa upper portion. So, ang kaning mga result, ato lang ang ipang squared using our calculator. So, for example, kaning 0.43 nga result. So, example na siya, negative 0.43 squared. So, ang result, ana, ang imong ibutang dari ang side. So, result, sa negative 0.43 squared, that is 0.18. Next, 0.57 squared, that's 0.32. Next, negative 1.43 squared, that's 2.04. Next one, 2.57 squared, that's 6.60. Squared, pwede ra siya i-multiply by itself kung dili ka kabalo sa squared. So, pwede ra 2.57 times 2.57, same result. Or negative 1.24 times negative 2.44, 43, 2.43, negative 2.43 times negative 2.43. The same result with negative 2.43 squared. That is 5.90. 5.90. Negative 1.57 squared is 2.46. And then negative 0.43 squared, that's 0.18. So that's our result in x minus x bar squared. Next one, we're going to add. Next step, we're going to add up all the data squared values. We have 0.18 plus 0.32 plus 2.04 plus 6.60 plus 5.90 plus 2.43 46 and then plus 0.18. 1 2 3 4 5 6 7. So adding it up, the result is erase that one. Again, i-add that tanan. Dari na lang a portion akong i-erase. So after adding it up, again, i-add mo ng tanan result diya sa x minus x bar squared. So again, our result in adding all the x minus x bar squared, we have 17.68. And we're going to use, so again, this is the result here. The result in x minus x bar squared is 17.68. So using the formula or following the formula, we still have here n minus 1. So we have n minus 1. 17.68 divided by n minus 1. Si n nag-represent sa data kung pila ka book data given. So we have 17.68 divided by 1, 2, 3, 4, 5, 6, 7 data. So we have 7 minus 1. So 17.68 divided by 6. 17.68 divided by 6. The result is 2.95. Since the actual result is 2.94666 and so on. We need to round it off in 2 decimal places. So we have 2.95. So this is our variance. 2.95 is our variance. It serves as S squared. Again, the result of our variance is 2.95. And in finding the standard deviation, we need to do the process as we recall the previous concept notes. In getting the standard deviation, we just square it, the given result of the variance. So we have S here, it serves as the standard deviation or the symbol of the standard deviation. Again, the square root of the result of the variance, which is 2.95. So we have square root of 2.95. Compute it in our calculator. 2.95. The result is 1.72. Since the actual result is 1.717556 and so on, two decimal places, round it off, we have 1.72. So in conclusion, we have our standard deviation. Result of our standard deviation is 1.72 and our variance is 2.95.
Variance DJ. Good.